Right, we have sound now. Welcome to the Royal Astronomical Society of Canada. We're an astronomy club. Are there any members of the public here? Okay, a couple. And a few Alzheimer's patients on the left there. Welcome. For those few of you who haven't been to one of these meetings before, we basically have a salad for the eye and mind, a large number of short talks. We're going to be talking about things you can see in the sky, observing adventures people have had, how to observe other things, reports of observations. Could you get the point out of it, please?
I thought that would help. I was wrong.
We have a fine tradition of heckling here at the RAC. Tonight we have an extremely content-packed meeting, however, so I'd like to ask the audience to hold their questions until we move out into the corridor after the meeting for conversation. After the observing challenges, we're going to have a break with door prizes because we all want free stuff. And then one of our favorite speakers, Simon Hammer, is going to talk. Simon is such a special speaker here that we've given him his own font. Then we're going to have a talk about how to buy and sell astronomy gear. And so you can see the progression here from what observing you can do, what observing people have done, to equipment. At the end, we're going to talk about the activities of the club itself with Paul Harrison, our new president, and Mike Mognahan, our new public outreach coordinator. So first is, our first crouton in this salad is Brian McCulloch, who's going to talk about what you can see in the sky right now.
Crouton. Okay. All right. And away we go. Okay, there you see the constellation of Orion, and you might have seen that just up as you were coming through the parking lot tonight. Okay, let's go to the next one there, Richard.
Your advanced button there, or you can just ask me.
Go ahead, yeah, thanks. There's been a comet discovered by a Canadian, by Rob Cardinal, and it was discovered in October. He's with the University of Calgary. Seems to be a lot of things happening at Calgary with Alan Hildebrand and that meteorite recovery program. Okay, if we go to the next slide. All right, we're going to see the comet. It's moving across here, here, here. This is your basic high-resolution photo. All right, so it's, right now it's in Ursa Minor. It's moving fairly quickly, and it's at just around 11.5 magnitude. All right, Tim had an idea that this would be a good opportunity to observe Mimas, one of the moons of Saturn, because right now the rings of Saturn are inclined just within about a degree of horizontal. So with the glare of the rings out of the way, it's easier to pick out the fainter moons. So here's where Saturn is, not to scale, of course, in relation to the constellation of Leo. And if you're going to look at the moon Mimas, check out the Observer's Handbook. Page 336, they've got that listed as an observing challenge for 2009. A lot of good information in there, and you should have no trouble at least finding out how to go about observing Mimas. All right, and that's in the morning sky. All right, Richard? Okay, evening planets. We've seen Venus, Mercury, and Jupiter moving along. And we're losing Jupiter quite early now, but if you happen to get a bit of elevation from where you're observing, and you'll see the nice line of planets with the moon up this way, right about now, and you see that nice line like that. And if you imagine, if you see Jupiter here, Mercury, Venus, and more or less where the moon is, that plane is the plane of the solar system. So if you built your model of the solar system on a kitchen table, put all the planets going around on the tabletop surface, and then tip the tabletop up like that, because, well, of course, the Earth is tipped back on its axis, 23.5 degrees, but we don't see ourselves as tipped over, we see everything else tipped up. That's the tipped tabletop like that. What's that? Yeah. Okay. And comet, does anybody know how to pronounce this one? Is it Lulin or Lulain?
Comet.
So it's a comet. It's pronounced comet. All right, that's the way to do it. Okay, so right now it's just up in the area of just above Sagittarius, Scorpius, all this region right in here. This is on the 9th of, this will be for tonight. What's tonight? 9th? This is where it is tonight at about magnitude 8.4, moving across the sky this way. And on the 21st of January, 31st of January, But when it starts getting into, here we are, the 10th of February, when it starts getting toward mid-month of February, you can see it's getting around magnitude 6. So they're talking about a naked eye comet. The only problem with this is, it's going to be in the morning sky. But the other thing is, so you're going to be wanting to observe around 5:30, 6:40, until about 6:45 in the morning, until you're starting to get twilight interfering. When you get out around 5:30, the comet would only be about 12 degrees above the horizon. And the closer you can get to twilight, of course, the higher up it's going to be, getting up to about 20 degrees before you lose it. All right. All right. So tonight, or tomorrow night actually, the 10th, all right, we're having the largest full moon of 2009. And it's the same as it was last year, when it was at its largest size. And when it's at its largest size, it presents a disk that's about 14% wider, and it gives about 30% more size to it. Okay, so you can see, here's a good, Tella's put this together, so you can see the difference in size between a moon that's at its closest approach to the Earth compared to one that's at its farthest point in its orbit from the Earth. So the average distance of the moon from the Earth is about 385,000 kilometers. And at its closest approach tomorrow night, it's going to be at somewhere around 357,500 kilometers.
Now, I'd like you to welcome Pierre Martin. Pierre Martin is the most active meteor observer that I know. In honor of his talk today, I'm wearing a few meteors. He's going to be talking about observing and other astronomy fun he's had. Pierre?
Thanks, Attila. Okay, well, good evening. I haven't done a talk in quite a while up here, so I thought for my first one I would speak a little bit about what I've been up to in the past few years, including some of my projects and interest, which obviously meteor observing is still my big passion, but also dark skies, attending star parties and public outreach, and also photography. So here I am getting ready for an observing session, or am I really? And I'm also going to include a little bit of madness in between during my talk. So, okay, so as some of you know, a lot of you might not know this, but I do own a coffin. It's not the kind of coffin you would think about. It's actually what it is. It's a series of sheets of plywood that are held together with door hinges. Everything unfolds and creates a box around my lawn chair. So I sit in the middle of it and cover the top with aluminum reflective tarps, so that gives me a little bit more protection against the weather, and especially the cold, since some of the meteor showers tend to happen late in the year when the weather turns quite cold. So next slide, I'm going to go through a little bit of my older pictures just quickly. Because every once in a while when I travel to dark skies, I'll occasionally stumble on a nice bright aurora if I'm lucky, or at least when the sun is active, which is not the case right now. So here we have this was at the La Vérendrye Forest Reserve back in 2002. We had a very bright display. It covered the whole sky, 360 degrees, really spectacular. And it was just by pure luck that we had a bunch of observers also set up with their telescopes. A lot of them drove up from Montreal and had their big Dobsonians set up. They had all their programs for the night, but this was obviously interrupted for the Northern Lights. And there's another view here. And at times the sky show was so spectacular that all the telescopes were basically abandoned, and everybody was just lying on the ground, totally speechless and motionless, just in pure awe of the display. And this was a view right up at the zenith, so it was basically shooting in all directions. Okay, and after the aurora subsided later on in the night, the sky got very, very dark. It was just about the darkest sky I had ever seen. And the Milky Way was just blazing overhead and even casting some faint shadows on the ground. It was really spectacular. And I took advantage of the dark conditions to set up my camera and my guide scope, and also to do a little bit of photography. So here's the southern region of the Milky Way towards Sagittarius. That's a single long exposure in that direction. Okay, I'm going to talk a little bit of just briefly on the Leonids, those famous Leonids that were so spectacular back in 2001. I know a lot of you were able to see them, and there's a lot of memories of that fine display. But a little bit less well known was 2002. There was also a couple of intense meteor storms where the hourly rates reached briefly almost 3,000 meters an hour for a short period of time. Now, this display wasn't as well known just because that year the bright moon was up in the sky and really diminished the display. And also the meteors tended to be a lot fainter than the previous year, which was very, very spectacular. Nonetheless, I happened to be down in Florida as I was picking up my newly made telescope at that time. And the sky was clear down there, so I figured, okay, well, let's include the Leonids into the trip and try to view this, even with the moon. Well, it turned out to be quite a nice display right before dawn, where the rates shot up very, very quickly, and I had a lot of trouble keeping up with the counts because they were coming down really fast. And here's my composite image. This is a composite of multiple frames that I took during the peak of the Leonids. And those streaks you see on the screen are actually the cirrus clouds that are just starting to move in. So I just managed to look in on time to see the display and the Leonids at their best before the clouds took over the sky. So, of course, meteor showers are not always as awesome and spectacular as the Leonids. Most nights, things are a lot quieter, which is typical. So what to do? Well, there is actually a lot of value in studying the minor meteor showers. In fact, those are the ones that are least well understood and the ones that require the most data from amateurs to help astronomers better understand how they behave and perhaps when the next minor shower might become a major one. So we just don't know these things yet. So one activity that's worthwhile on those quiet nights that I enjoy doing is actually plotting meteors on the star chart. So this view here that you see is actually inverted, so it's a little easier on your eyes. So it's white paper with where I'll draw the meteor paths against the stars. And this is especially useful to try to determine the structure of the shower radiance. Sometimes it's not just a tiny point where the meteor seems to originate from, but it could be a complex of different radiants. And also, quite possibly, among the sporadic background, there could be some undiscovered meteor showers. And in fact, they keep finding new ones every year, the very minor ones that might one day become more important. This example here shows the 2004 June Bootes. It was quite a beautiful shower of very slow-moving meteors. The only thing was that shower happened right in the middle of June. It was really hot. It was very humid. I was way out in the woods in observing this. And I had a lot of trouble seeing the stars on my chart. It looked nowhere near like this when I was plotting. So why? This is why. Speaking of mosquitoes, there's this great little device that came out on the market recently. I'm not here to try to sell you anything, of course, but I tried it out this summer. It's called a thermosol. It's basically a little appliance that works with a butane fuel and a little heat strip. And it emits an odorless fume that we can smell, but mosquitoes apparently really hate. I did a test one night where it was really bad. There was a lot of mosquitoes, where I turned off the unit. I wanted to see, well, does this really work, or are the mosquitoes just gone? And as soon as I turned it off, it wasn't 5 minutes, and I was being eaten alive. So it really seems to work well. One indication was last summer, it was really hard to find this in the stores. It was being sold out everywhere. So that could be maybe a sign that for once there's a mosquito product that actually works and won't have your fingers all sticky with bug spray. Okay, now a little bit more on the auroras. A few years later, 2005, I was over at the La Varenge Forest Reserve again, and I saw this beautiful display over the north horizon. It produced a nice wide arc, quite spectacular. And since I had my camera and my tripod, I figured, hey, I'm going to try something different. And I decided to try a panoramic view to try to capture that whole arc. So I set up to take 3 pictures side by side and fairly quickly, so I wouldn't have too much motion or blurring to the aurora, which would not work to try to stitch it afterward. So this is the result of it. And here's a different aurora later on that summer, this time Algonquin Provincial Park. with the reflection above the water. Now, a little bit about the 2006 Perseid. So we're going back, we're actually moving 2 years now to 2006. In all honesty, it wasn't the greatest, the most spectacular shower. The reason being the moon was full that year in 2006. So the counts were drastically reduced to maybe only about 20 an hour or so. But for me, it was still an all-nighter. Like I not want to risk missing anything in case something happened that was unusual. So I wanted to be out and watching this and taking pictures. So what I did is set up my cameras to with a timer to automatically take time exposures while I could just lie back in my lawn chair and enjoy the show and take care of my observations and not have to worry about the cameras. And this worked out really well. In fact, there was this bright fireball that appeared late at night, and I'm really glad I had my cameras because I never saw that bright meteor, and I'm sure it would have been spectacular. And why is that? Well, there's a reason. Okay, now for the 2006 Geminids. This was going to be a good year for them. It's not always that we have the peak centered right on our longitude, and this year it was going to be right on, and we're going to have the maximum rates for the night, which was December 14. So I was determined. I told myself I need to go out and see this at all cost. But there was one problem, is that the satellite pictures or the weather maps 1 day or two before showed this kind of thing. It was clouds everywhere in a few hours driving distance from the city. So most people would just stay home, just relax and do their Christmas shopping, do stuff like that. But no, that's not what I did. In one moment of insanity, I decide that I'm going to do this 1,800 kilometer trip to Central Tennessee on my own. And I figure, okay, you know what, if I stop only for gas and for the odd quick bite to eat on my way, I should be able to make it there on time for the shower and be able to set up. And that's what I ended up doing. So it was actually worth it. This is the composite picture that turned out from running my camera all night in one area of the sky, and all the Geminids that are coming down. And you can see right in the center of the picture, there's actually two sporadics that are going against the flow of the Geminids. So it was definitely a good shower. The rates surpassed 100 per hour, which was right above the peak rates as expected. And here we see actually a double Geminid going down into the trees, taken from my second camera running also. Now, obviously, comets are another part of my interest, since comets are actually the origins of Earth's meteor showers. And this is a comet McNaught from early 2007. I was able to take this picture from the experimental farm. And it was just a short window right after sunset where we could see this really bright comet into the western sky before it sunk out of sight. And it was a really great show, but man, was it ever cold. Talk a little bit about the Orionids. A few brief notes. Normally the Orionids, it's a moderate shower, and they peak usually somewhere down here, about 15 to 20 per hour. And in the past few years, it's been nothing like that. The Orionids have been unusually active, 4 times the normal rate actually, and with a high proportion of fireballs, which is really totally unexpected. So it just goes to show how much we still have a lot to learn about meteor showers. And luckily enough, I had some clear skies for the 2007 Orionids, and managed to take a number of composite pictures. This here is facing right into Taurus with M45 and the Hyades. And as it turned out, the 2007 Orionids were just about the most photogenic meteor shower since the Leonids. It was really quite spectacular. And here's a view towards Orion. And you can really see all the meteors streaming right out of the radiant, which is just off the picture. This was taken with my wider angle lens, a 20 millimeter, in fact. And I was also lucky enough to capture one of the bright fireballs. This was about a magnitude -6. And you can actually see this brown stuff here is actually the persistent train that lasted a few minutes after the meteor disappeared. So it was really quite a display. And even the night after, and it was a broad peak, the night after I went out again, because I figured, okay, well, there's something really interesting going on, but I had no idea that the night after the predicted peak would actually turn out to be even better. And this was the case. This is my composite from that morning. And I used the background sky. I used a morning twilight scene just before the sky got bright and the stars vanished. Okay. And of course, everyone remembers Comet Holmes, really spectacular. And of course, I tried to capture the blue tail of Comet Holmes, but I wasn't able to. So this was my improvised version of it. Now I'm going to talk a little bit about more recently, up into 2008. One of my other interests is doing some public outreach. So here we are, set up for the lunar eclipse in February 2008, and it was really cold. But actually, we had a good turnout. We had quite a bit of the public show up, and also telescope volunteers. And this was my composite creation of the different phases of the lunar eclipse. So you can see from the beginning right up until totality. And going back into the summer, one of my projects I wanted to do, and I was inspired a little bit by my earlier aura panorama, was to actually try a panorama, but on the Milky Way with a wide field with a wide field lens. So what I did here, and this is actually rotated so that the horizon is down here, so I could actually fit a little bit more onto the picture. And just for reference, this is the star Deneb and Vega Altair, and down here this bright one is Jupiter, which is sitting right next to the teapot or Sagittarius. So what I did is I simply took 3 long exposures, one near the horizon and then halfway up and then basically straight up, and stitched them together in Photoshop to create this image. Earlier that evening, I was actually surprised by something else that was completely unexpected. It was a display of noctilucent clouds. Now these, this is a high atmosphere phenomena, or clouds that form at the upper reaches of the atmosphere, almost in space. They are very uncommon for, especially for around Ottawa. And one of the interesting bits is that meteoric dust, the stuff from meteors, might actually be responsible, or one of the mechanisms responsible for the formation of these elusive clouds. And now for the Perseids. I was lucky enough to have a clear window this past summer and had a great view of this shower, which reached rates of over 70 meters per hour. At least that's what I saw. And I was set up at 2 hours west of Ottawa. There's a really nice dark place that's called Nirvana, and it's an abandoned airstrip, also known as the Irvine Lake Airstrip. And luckily enough, I had a clear hole above that area, and I did this composite of the meteor shower with my camera aimed into the Milky Way. And this is also the Perseids with my second camera facing the Andromeda Galaxy with the meteors scooting by. And there's a tiny sporadic right over here. And the next morning after the Perseids, just to show you the camera setup, the platform and the various DSLRs set up on top. And then the other significant event, for the long weekend in September in 2008, there was a number of us that decided to head out to Nirvana. We noticed that it was going to be 4 clear nights in a row, and that's pretty uncommon for Ottawa. So we figured, hey, you know what, let's go out and set up the tents and the telescopes and maybe go out for a few nights. It turned out it almost looked like an impromptu star party because we had not only people from Ottawa but also people from Kingston and Belleville who showed up and had a great time. So just going to flip through a few of these here, the different telescopes set up. And there we are getting the barbecue ready. And here we have Joel Silverman, who's investigating bait left by the hunters to attract the bears. And there's the evidence. Although, thankfully, we survived the night in one piece, so we were able to get back to tell you about it. Okay, now one of my projects that weekend at Nirvana was to try some wide field imaging with my telephoto lens, my 300 millimeter lens. I was especially curious to see how much I could capture under those really dark, pristine skies. So I decided, hey, I'm going to show you a single, long, manually guided exposure. No dark frames, no flats, just keep things simple. And then I realized, hey, you know what? I have my little refractor with me. I can just use that little refractor and set it up on my camera platform that you saw earlier. Use that little refractor as a guide scope. So I would put it in the illuminated reticle eyepiece and look for a guide star and basically make sure the guide star would be centered into the crosshair that you see on the screen. So this is the view that I would look into the eyepiece. So I figured, okay, well, you know, that's a good way to compensate for any tracking issues in my mount. If it's not perfect, I can just press the buttons on this keypad right here and make sure that I keep it well centered. So this, of course, would demand my full attention. Any errors or any inattention, I would have to start all over again, which means obviously wasting precious dark minutes, or precious dark skies, I should say. Sounds simple, sounds rewarding and fun. Well, let's give this a try. First attempt, okay? I'm doing this guiding and things are going well. Oh no, geez, I just bumped the tripod. Now let's pretend that this star has flew all the way up here. I gotta start over again. Okay, second attempt, no problem. I'm doing this, pressing the buttons and tracking, doing the corrections. Oh geez, I knocked the eyepiece. That doesn't work too well. I gotta start over again. Third attempt, no problem. I'll get this done. Okay, 10 minutes are going by and I'm doing this guiding. Oh great, look at this. What's going on now? Bad cable or power failure? Now just about half the night is gone. Now I tell you, I've just about had it. Okay, now, next slide. Eventually, though, I was successful. So after all that pain, I managed to finally get my shot of the North American Nebula, which is, like I said before, a 15-minute exposure, single shot, manually guided. And the sky conditions were excellent. We had great transparency in seeing. And after the star party, I post-processed this into Photoshop to try to bring out the details. And lastly, this is was my other area of interest in a very star-rich area in Cygnus. You can see there's a lot of dark lanes and a lot of dust into that area, which all seem to culminate into this star-forming region that's known as the Cocoon Nebula. So that's it. Thank you. Thank you.
Thank you, Pierre. I find observers like Pierre and the stories they tell inspiring because, for one thing, it shows that old ball guys like me can maybe have a chance of having fun too. Oh, I'm not sure the fun is contagious. Being a deep sky observer, I'm always interested in finding ever new ways to improve my sleep deprivation. And solar observing is one way to do that because you can stay up all night and then stay up all day and stay up all night and stay. Anyway, to talk to you about how to do more sleep deprivation, I mean solar observing, is Ken Whitnall. Please welcome. Where is it?
This one here? Hello. Okay, so I've never done this before. So this is our deal here, is it? Okay.
Push the right button here. Should
Okay.
get to the title slide.
All right.
That's your first slide.
All right, terrific. Turn around so I can see what I'm doing here. Good day. Today, or this evening, in this presentation, I'd like to talk about hydrogen alpha solar observing. About 4 years ago, I bought my first hydrogen alpha solar filter, and it was magnificent. The sun is so dynamic when you compare it to other things when you're looking at night, where things very rarely change. The sun is changing all the time. I thought I'd start off the presentation of this wonderful photograph from Pete Lawrence. You see some wonderful clouds of hydrogen there above the surface of the sun. In this presentation, what I'm going to try to do is talk about H-alpha light, where it comes from, and exactly what it is, and some of the things that you can observe in hydrogen alpha light. Here's a picture of the limb of the sun. This area here is the photosphere, or the sphere of light. It's about 500 kilometers thick, and it's the end of the convection zone of the sun. It's an area where the temperature goes down to about 5,500 degrees Kelvin, and just above it is the chromosphere. The chromosphere is about 2,000 degrees thick, and for some strange reason, it's not exactly known, but the temperature rises from about 6,000 degrees Kelvin at the top of the photosphere to about 50,000 degrees Kelvin at the top of the chromosphere. The chromosphere is transition zone between the photosphere and the corona, where the temperature will soar again into about 1,000,000 degrees K. Important thing to understand about this whole region here of the sun is that it is a plasma. Now, plasma is a realm where there's still a lot of free electrons in all of the elements. There's an awful lot of elements in the sun where they exist in their full atomic form. Of course, about 70% of the sun, the solar material is hydrogen, and there's other materials, there's other elements like oxygen and nitrogen and calcium and silica and things like that. Now the chromosphere, another name for the chromosphere is the sphere of color, and it has these large forms of nitrogen plasma that is suspended above lines of magnetic field lines. Typically, you'd never be able to see the chromosphere, but in a total solar eclipse, you can see the chromosphere as this brilliant ring of red because the electrons are excited because of the high temperature, and they give off light in the red part of the spectrum. Now, what you're actually looking at here is a spectrum of the solar disk in visible light, and it's actually one long row, except it's all stacked up on top of one another. When the German astronomer Joseph von Fraunhofer studied the spectrum in 1814, he discovered that they had all these very dark intersecting lines here. And those lines nowadays are actually known as the Fraunhofer lines. In actual fact, what they are absorption lines where the atomic activity, where the electrons in the atoms, as they as they get very, very excited and move into outer shells of the electron orbits, they absorb a photon. And when they absorb a photon, they will leave one of these dark lines. And just in this area here, you can see that there's a very strong Fraunhofer absorption line, and this is in the hydrogen alpha here, deep into the red. Now these lines are actually very important. They allow solar scientists to analyze the chemical composition of the sun, and they also determine densities, temperatures, and wind speeds. These spectral lines are also critical tools for the detailed exploration of objects from a distance. But why alpha? Why hydrogen alpha? Here we have a model of the hydrogen atom, where you have the nucleus in the center. And what these concentric lines here are the outer, or the various orbits of the electron orbits. Now, the issue with these orbits, of course, the hydrogen atom only has one electron, but if it gets excited and gets put into a higher state of energy due to temperature and pressure, it will move from a lower energy orbit into a higher energy orbit. And when that gets dropped down, or if it's ionized and accepts a free electron, the electron will drop down into a lower orbit of energy. And what in actual fact happens, you have this spectrum here of absorption lines and another spectrum here of emission lines. Now, Swiss astronomer Johann Balmer studied these Fraunhofer lines in the later 1800s. And he studied the hydrogen atom in various states of excitement, and he came up with the Balmer formula that actually showed that when an electron moves from the N3 orbit into the N2, it will emit a photon. And it'll emit a photon, and that wavelength of light is right at 656 nanometers. Or more specifically, 6,562.8 angstroms. And this is known as the hydrogen alpha line. Now, in successive orbits of higher energy, he named his lines alpha, beta, gamma, and so on. And these are just absorption lines and emission lines from the atom or the electron falling down from N4 to N2 and N5 to N2 and so on. So that's the hydrogen, that's the actual hydrogen alpha line, and the reason why they call it hydrogen alpha. So, the hydrogen alpha is, because we're actually looking on the surface of the sun itself, we can see an awful lot of activity. The hydrogen alpha wavelength is in the visible spectrum, so it can come right down to Earth. It's not absorbed by any of the Earth's atmosphere, and we can see it with our eyeballs in the visible light. The sort of the things that you can see in hydrogen alpha light are prominences, which are here on the limb. Now, the prominences are the easiest feature to see in hydrogen alpha light. And you can see that with a filter that has got a fairly wide bandwidth of about between 1 and 2 angstroms. And the darker features that you see here are the filaments. Now, in actual fact, the filament is essentially the same solar activity as the prominence, except that the filament is has the photosphere in the background, where the prominence is seen on the limb with space in the background. Now, there's two types of filament prominence. One type is a quiescent type, or a quiet, and it's where these clouds of hydrogen plasma will coalesce along magnetic lines that can go across the surface of the sun. And sometimes the hydrogen clouds will coalesce together between opposite polar regions. And sometimes they can be very explosive magnetic fields, where it'll burst out a lot of solar plasma into outer space, where these field lines would break and toss a lot of activity out into space. So the other type would be the active type. So active and quiescent are the two types. Other things that you can see is the granulation in this higher magnified image here. The granulation you can see is kind of like a modeling of the surface of the sun, and these granules can be between 1,000 2,000 kilometers in length. They're quite hot, and they're cooler and darker along the sides. And it's the top of the convection zone, so just like a pot of porridge, it's changing all the time. Now this active region here is an area where it's a higher magnetic activity. It hasn't actually developed into a sunspot, but you can see where the granulation has moved in towards this this magnetic activity. And another thing that you can see in areas of high magnetic activity, as well as areas near sunspots, is these white clouds here known as plague. Now they're white because it's an area of a lot higher density, and they're much hotter as well. But they're typically associated with sunspots and areas of high magnetic activity. In the white light, the same feature is known as facula. And here's a slide just to talk about the different classes of prominence. You have your A to E here, which is your quiescent type. Typically, that is the activity that is just forms over filaments, and the more active explosive activity is the type of prominence that would be more associated with sunspots. Now, the last thing that you'll be able to observe in hydrogen alpha light is this odd feature known as spicules. This is the area in here, which is sort of like this grassed area, and there's these many thousands of these little spicules sort of sticking out here. Spicule is a dynamic jet of about 500 kilometers in diameter on the sun. They were discovered in 1877 by Father Angelo Secchi of the Vatican Observatory in Rome. The spikes of superheated gas are small compared to many suns' prominent features, such as giant loops of magnetic energy that are flung many thousands of miles into the solar atmosphere. The spicules are typically 500 kilometers in diameter and shoot at a relatively modest 5,000 kilometers above the sun's surface. They stream about 22 kilometers a second, and they vanish within 5 minutes or so, 5 to 10 minutes. It makes them very difficult to study. However, in 2004, a team of solar physicists and upper atmosphere research group of the University of Sheffield in England used the NASA's SOHO satellite and the Swedish 1-meter solar telescope and the NASA's Transitional Region and Coronal Explorer satellite. Together, the observations enabled the team to pinpoint how often and where the spicules appeared. They showed that spicules are formed by sound waves which have the same 5-minute period. Plasma bubbling upward from the sun's interior to the surface creates a drum-like cadence, although the sound waves usually are dampened. Under certain conditions, they leak into the atmosphere or chronosphere, spawning shock waves. These waves propel the plasma, producing more than 100,000 of these spicules at any given time on the surface of the sun. Now, you typically wouldn't be able to see spicules so much with your average amateur equipment. I haven't seen them myself with the telescope that I have, but I'll be looking for them. You know, they only last about 5 minutes, and there's many, many of them. So you should be able to see them if you have enough aperture. That's it. Yeah.
Thank you very much. Thank you, Ken. I believe that was Ken's first time here on stage, so be nice to him. Okay, now we have a section called Observing Reports. This is an opportunity for all the expert astrophotographers around here to show us their wonderful work, and an opportunity for the visual observers to tell us what they've seen, although it's kind of a little hard for the visual observers to illustrate what they've seen. And that's what I thought was happening with Roman de Zorba's submission today. He's an Ottawa member. I just couldn't figure out what the heck he took these pictures of for, because anybody recognize these star fields? They look like nothing to me, until I turned the gain up. On the lower left, he's got the Southern Cross and the coal sack. On the upper right, he's got the Large Magellan Cloud. Roman has escaped to Australia to avoid the Ottawa winter. I think he should be congratulated or envied. Next, we have a couple of pictures by Paul Commission. Paul, would you like to describe them from your comfortable seat?
Yes, this is a small open cluster in Cassiopeia. It's about 4 minutes in diameter, about 9.5 in magnitude, easily seen with a small telescope. It's one of those winter type of open clusters that are plentiful around Cassiopeia. This is an old favorite of mine. It's 891. This is an Andromeda. It's about 10.5 or so. Also easily visible in a small telescope, and it's a nice object. It's in Andromeda, not too far from the Great Andromeda Galaxy, so it's easily found, and it's a nice object to observe at this time of the year. Oh, this is your favorite. I just brought that out especially because you were talking about it, Attila. That's the old favorites, 7332 and 7339. 32 is on the right-hand side, and 39 is on the left-hand side. Now, 32 is about 12th magnitude, not too bad. The other one, the 39, is a little harder to see. That's a 13.1. So, and they're, again, they're in Pegasus. And at this time of the year, they're not. Probably you could see them with a C11 or something like that. You could see them in a good dark spot.
Okay, thank you. Next, Peter, are you here?
Okay. I just got the scope out one night and just was taking a nice shot down the Terminator and happened to discover this little fellow here. No, I'm not the sole discoverer. Other people have discovered it before.
Peter, isn't that one of Brian's lunar challenges?
I don't think so. I don't remember that
It
one.
wasn't this month, but it's actually, I've seen the X being discussed on some internet groups. It is considered quite a challenging object.
Yeah,
so.
it is.
Yeah.
Well done. This is a very rare sight.
I don't know. Yeah, I thought it was pretty rare because I'd never seen one before and never even heard of one, and was quite shocked to see it there.
Can you point it out
So-
with your pointer? Laser pointer right in front of me. The skinny one. Skinny one.
Yeah, there it is.
You discovered it all by yourself?
No, other people have discovered it
No,
before.
you
But on the
knew
night,
about it before.
I didn't know about that before,
So
though.
You
Yeah.
discovered it for yourself?
Yes, I did.
Awesome.
Yeah, I know. I think it's probably actually just about 4 craters around. In fact, I think that this side here is probably from this crater here. Just beyond the Terminator there. I think you can see the general shape of this one too. Maybe this one, I'm not sure. But those two look pretty definite. Yeah. Alright, now, I believe last month I showed the incomplete version of this, and it was cut off about here, and the transitions were not very smooth, but I looked at it and decided to rework it completely, and I spent a long time matching the exposure on each image, trying to make sure that they were as close as I could get them to being exactly the same tone levels and everything. You can see I tried my best up here, but they're still fairly visible. But I included a few more images, particularly this one here, and I think over here too. I think in total it's about 9 or 10, all taken on the same night. But not the same as the Lunar X night. That was different.
You waited until Attila was meeting chair before you brought your best one in.
Pretty much.
You've been planning this for years.
Now that Brian's gone, I can show a moon picture. This is also a mosaic, and I took this because it's we're supposed to. I think we're supposed to learn these craters here, all the gateways, the 2 gateways. Well, it's just a bunch of craters. I didn't learn any craters. But one thing I should say about this picture is that I'm always envious of Paul Commission. He takes these pictures like 8 seconds, 1 minute, 40 seconds long exposure to them. And I do them like for 2 days, 3 days. This Paul was 1,000th of a second. Okay.
What's the size of your scope?
This was taken with an 8-inch Newtonian. This is the challenge object from last month, and it was the challenge object is down in here, and so I thought I'd just show you what it was like. The M31 here is a 7-hour exposure taken back in 2006, and I took a star chart and matched that one up as best I could. That's about an hour and a half, and it's G1, which is a globular cluster. I assume it's near Andromeda.
It's 200,000 or 300,000 light years away from the core.
From the core. So it's anyway. This little feature right there is it, and Attila described it as Mickey Mouse ears, and boy, it really does look like that. And when I zoom in on it a bit, same picture, just zoomed in a bit, you can really see it now, the Mickey Mouse effect. And the cluster is the center. I assume it's the face. So that's a globular cluster that's basically 2.5 million light years away. Kind of neat. And it showed up. I don't have a very long focal length on my telescope, so that's about 800 millimeter scope. So it's I got a much better picture than I thought I would. Okay, and there it is there labeled again. This is one of my favorites, is M42 in the Orion Nebula. And it's this was taken on February 13th, 12th, 18th, 20th, 21st, 25th, and a total 10 hours. And it's a mosaic. My scope doesn't take that big a picture. The colors are fabulous. I just love the way the colors in the Orion Nebula show up. And the trapezium is right there, and they're actually resolved. 4 of the stars resolved pretty nicely. When you look on it on monitor, you might be able to see that. All right. There is a supernova in the sky right now, and it's in M61. And I thought it'd be so neat to to go back and get one of my old pictures of M61 and then compare it to the picture I take now. And I found I hadn't imaged M61 before. There's not very many Messiers that I haven't imaged, but this is one of them. And so I took the image of it, and that's my image. And it's about a half-hour picture. It's about a half-hour exposure. And you can see as I flip back, this picture was taken by Adam Block, by the way. Whoops, sorry, wrong direction. As you can see there, the supernova is showing up really clearly. And that's apparently visible in naked eye, though it's getting close to the limit. Okay.
Thank you.
I believe that's it. Thank you very much.
Okay, so this is not quite a mosaic yet, but the idea here is, well, let me see. I have not seen this control before.
There's no laser on that. It's the
Oh, okay. So the idea here with where's the light? Ah! Okay. So the idea here is that you know, when you take an image of the moon or when you see the moon, it's really just this narrow strip along the terminator that shows any detail. So the idea here eventually will be to build up a series of these and just take this strip of near the terminator where there's enough detail to see the craters and make up one image of the moon just using these little strips. Now theoretically that should only take about 2 weeks from new moon to full moon, but at the rate that, you know, we get clear skies, it'll probably take me about a year. So this is a whole disk with one image, but you know, this could have been made with multiple images too, but it just gets out of hand at some point. Okay, next. Oh, actually, I can do this, right?
Or I can.
No, I'll do it.
I'll have it.
So which button? Let's try that one.
Right button.
Okay. Okay. So this was mentioned earlier, and as being something you could see in the evening sky. And okay, I'm not sure what happened to the label for Venus, and I'm not sure why the color changed, but that's, oops.
I'll go back for it. Oh, or you go.
Are we missing an animation there, Phil?
Well, okay, so there was a label here for Venus, but I guess it's black now. It used to be white, and I guess that's why we can't see it. And there is Mercury and Jupiter just about to set, and this was on January 3rd, so Jupiter you may not be able to see anymore, but certainly Mercury should still be around for a few days. Okay, now the Deep Sky Challenge. So this was the central part of Orion that I took just a couple of days ago. We've all the clear weather we've been having has just been the last few days before the meeting, so it wasn't too easy to get the pictures, but I took this with the moon about 20 degrees away, so the sky wasn't very dark. So this is the central part of Orion, and there, of course, is M42 that Bob just showed the excellent close-up of. But the part for the challenge, I guess, we'll zoom in on this part here. This is the belt of Orion, and this is the star Zeta Orionis. And there's some very interesting objects around that, so we'll just zoom in on the same shot. This is just an enlargement from that image. Okay, good. Now at least it's white, so we can see it. So there's the star Zeta Orionis. And this star represents part of the challenge because it's so bright, it makes it hard to see some of these other things, which are rather faint. The easiest one to see, which you'll see in almost any telescope, is this, called the Flame Nebula, NGC 2024. The next thing that would be fairly easy to see, I guess, it might need a larger scope, is this thing here called NGC 2023. Wait, before I forget, the Flame Nebula is an emission nebula, and just like in the talk before, it's an emission nebula in hydrogen alpha. So anything that you see in the sky that's red is probably emitting an hydrogen alpha. This is actually a reflection nebula surrounding this star, and it's kind of whitish. So it's not going to emit in a single color, but it is basically just reflecting the light from the star around it. And then the final object that's much more difficult is the Horsehead Nebula, which is this little dark spot right here. And now, so I'm just showing this for illustration. What you should really do to try and find the Horsehead, and again, it's going to need a very dark sky. The Flame Nebula you can probably see fairly readily. 2023 maybe a little harder. The Horsehead will need a very dark sky, and the best way to go about finding it is actually to get a photograph of it from the internet, and basically just try and follow the star patterns until you see the Horsehead, and make sure that the Zeta Orionis is out of the field of view. And a filter also will help. Any kind of a light pollution reduction filter or hydrogen alpha filter, something that passes the hydrogen alpha light but rejects other light, just to improve the contrast. So that's it.
Okay. All right, here we go with a quick lunar challenge. This is from the Isabel Williamson Lunar Observing Program. You can order the handbook for this observing program from the RASC. I believe it costs $15. So this is the Isabel Williamson number 18. It's for Palus Somni and Crater Proclus. So Palus Somni is known as the Marsh of Sleep. So a palus is a marsh. And here's Crater Proclus. Now what they're calling for in the challenge is to identify the palus right here, and also the crater, and to do a sketch of the Proclus ray system. Now the rays, we'll see in another photo in a second, shoot up this way and shoot down this way and come across into, this is Mare Crisium on the eastern edge of the moon. Now what we're going to do is we're just going to skip over a couple of slides quickly here, okay? And here's the close-up of that now. So Mare Crisium is way over here. This is the Sea of Tranquility. Houston, the Eagle has landed. Right? Here's the crater Proclus. It doesn't rise very high above the surface of the moon, but it goes down fairly deep. It's going down almost 2.5 kilometers below the surface of the moon. It's a 20-kilometer wide crater, and it's the second brightest object on the moon after the crater Aristarchus in the northwest. So now you can see Palus Somni here, and what they refer to this as one of the continental features of the moon. This is the flooded up lava basin of Mare Truncellitatis, with the inroads coming in, these two sinuses. Okay. Crater Lyell for identification here, Crater France. And you can start to see how the rays come here and are extending, they'll go right across that way, but there's nothing coming back this way. So the theory is that it was a low angle impact from the west, kablang, threw everything out this way, threw nothing back this way. So observe it, photograph it, sketch it, whatever you want to do, make notes on it, and see what you determine from that. All right, and we'll just go to the next one. Yeah, keep going. And again, okay. And I'll talk about those other ones that we've just passed over. We'll do that another time. I was photographing the moon and observing on, I guess it was last Saturday night, and I'm looking along the terminator, that line of craters, which if anybody, Bob Olson, if you bother to identify which ones were which, right? All right, there's the crater Ptolemaeus, and there's Alphonsus and Arzakel. But I'm looking in here, and what I'm looking at is a picture of, do you see what I see? What do you see there? Let's go to the next one.
Simon, remember Simon? He's the guy with the special font because we like him. Just a note. As amateur astronomers, we spend a lot of time looking into eyepieces and yelling, "Oh wow!" But our appreciation of what we can see greatly increases when we know a little bit about the physics behind what we're seeing. And I can think of no one who does a better job of explaining the underlying astrophysics or knowledge behind images is Simon. Is he here? Ah, wonderful.
Alrighty,
Sorry.
thanks. A few weeks ago, Mike Wirtz got in touch with me and said he'd got some new images of the moon. And he asked me if I would actually present them for him at the RASC. For those of you that don't know who Mike Wirtz is, Mike is a member of the RASC here in Ottawa. He's no longer living in the region. He was living in the Perth region, I believe. He's probably, I think, and I think a lot of people think, the best lunar photographer, imager in the world. So when he asked me if I'd present some of his images, for me this was a great honor, and I jumped at the opportunity. Before I actually get onto these images here, I just want to remind you of what you're looking at when you're looking at the moon. You know, we look at these large basins here, and we see all this white stuff, so we see dark and white. Remember what the white is. The white is a material called a northosite, and I always tell people this is more or less a rock of the same composition as the old original coffee mate. And the dark stuff here, the dark stuff here is actually lava. It's the same composition as the lava that makes the underpinnings of the ocean basins here on the Earth, and it's called basalt. And you can see where Mike's photographs are coming from here, where these red boxes are. These will come back later in the talk. but they're focused essentially around the Imbrium impact basin. I always get myself mixed up here. Serenity and Tranquility, or am I the other way around? I can never remember. The important thing is, what are these things? These are impact basins which formed early in the history of the moon. They're much, much larger than the impacts which formed the craters, and they formed multi-ringed impact basins, which then filled with lava. But not at the time of the impact, which you might think, but millions, hundreds of millions of years later. So that's an important point to actually start with before we actually get to Mike's images. Now, I wanted to tell you something about Mike, and for those of you that don't know him, here's Mike. This picture was actually taken, I believe, possibly last week. Mike has moved from the Perth region. He's now living down at his Equilus South Observatory in Baja, Mexico. So just to really annoy us, he sent us this picture of him by his 18-inch telescope, which is a Star Master. He uses a Luminera Infinity camera, for those of you that know about this stuff. And his images, he stacks a whole series of very short time exposures, between 120 to several hundred, to achieve the images that he has. So here he is in sandals, shorts, and t-shirt. Now, the one thing that I was at least pleased about was, at least I can see that he doesn't have a perfect horizon to image with. And if we go to the next slide, oh, we missed it. I thought that we would actually put, I was told that a slide had been slipped in here showing that it had in fact snowed in this area only a few weeks before.
I took it out because I wanted to maintain the impression that Mike had escaped to heaven.
Well, I guess he has. So let's take a look at the kind of heaven that Mike's actually looking at. So let's go to the next slide. So we'll start up here on the northern side of the Imbrium impact basin, around the vicinity of the crater, impact crater Plato. So what are we looking at? What I want to do with this particular image, I'll take a little while with this one here, because it really underpins what you can do as amateur astronomers with almost any size of telescope. You won't see what Mike sees, but you will see the same kinds of elements, and you'll be able to tell the same kind of story. And the theme that I really want to leave you with throughout this talk here is the idea of time sequence. You too, just as we will be able to do with these images here, you'll be able to see a time sequence from older to younger and actually see how the lunar processes evolve through time. Geologists and selenographers, which is what geologists who look at the moon should really be called, they call this stratigraphy. Now, if you look here, you can see we're on the northern margin here of the Imbrium Basin, and you can clearly see what are called the Alpine Mountains. And these things are actually the flooded. When I use flooded, I don't mean water, I mean flooded by basalt lava. These are the flooded remnants of the outer ring of this multi-ringed impact basin. And if you look at this carefully, you can see in Mike's image, you can see that there are quite spiky looking hills here on the south side, and then there's this rubbly looking texture here on the north side. Well, this here is the arcuate relic of the actual ring of mountains forming the outer ring of the multi-ring impact basin. And this stuff out here is the ejecta that was thrown out of the hole when the major impact occurred. So you can actually differentiate that even with a relatively small telescope. And if you've got a pretty good imagination and a half-decent telescope, but it doesn't have to be very big, you can actually see that these hills down here, the Piton and Pico, and then the Tenerife Mountains right here, and then just down here in the corner, this straight ridge here, as it's called, the straight range, this, many suggest, is the arcuate inner ring of the multi-ring basin, and again, drowned by the lavas that filled the basin. Now, as you look at the northern ridge here, you can see this here, the Alpine Valley. This is probably the most classic valley on the moon. A lot of people look at the moon and think, oh, it's all about craters and impacts. It's not. There's a lot of selenography, geography if we were on Earth, that you can see that's other kinds of features, and features we can recognize similar to what's on Earth. This is actually a rift valley, rather like the Ottawa Valley is a rift valley. If you go to the early escarpment over in the Gatineau Hills, you're standing essentially on this side, looking across this rift valley. We'll say something more about this as we look at another photograph, which will show us something closer. But you notice that the Alpine hills out here are actually pockmarked by craters, impact craters. Well, when we get in there, you'll see that the valley here has a flat bottom. And it doesn't look like there's much in the way of impact in there. That'll tell us something about time. The other major feature here, of course, is the impact crater Plato. This is important. Some of these craters are simple craters. That one up there is a nice simple crater. It's just a hole in the ground, basically. But a complex craters tend to be larger, they usually have, this one doesn't, and for a very good reason, they usually have a central peak in the middle there. And then they have these ridges and terraces coming around the outside. You can even see them here at this magnification, and even large slump features. They're essentially landslides. In other words, the walls of this really large, complex impact crater collapsed inwards into the hole, and you can actually see it happening. Well, this is interesting. The floor doesn't actually show the central peak, and in fact it's a flat floor, and there's actually not much action going on in there in terms of impact. And the fact that there aren't many impact craters inside the larger crater tells us that that floor is relatively young. And in fact, it looks just like the lavas that fill the major impact basin, Imbrium. So these are actually lavas of the same age. And just as these lavas here are drowning the edge here of the multi-ring impact basin and are therefore younger, so the floor of this crater here is actually filled with lavas, which actually came up through the floor itself and filled it and drowned it. So that's actually a drowned crater. So these lavas, again, are younger than the actual impact basin itself. Okay, let's just move on quickly to the northeastern edge here of Plato. And you can see this squiggly valley. That thing there was not carved by water. That valley is in fact the result of lava. Look at the, if you can see it above people's heads, the scale bar down here is 100 kilometers. This squiggly valley is well over 100 kilometers long. And that actually is a collapsed lava tube. It's probably a kilometer or so in width across. So it's huge. Why do I think it's a lava tube rather than a lava valley carved out by erosional lava flow? Because if you now look up here, in the extension, just around these hills here, you can see it seems to continue on and then flow out onto the floor of the northern cold Mare Frigoris, or the cold sea. But if you look carefully, you can see that instead of it being a long, continuous valley, it's in segments. There's a gap. There's another bit. Then there's a gap. And then there's some more here. And in fact, what this is was a tube of lava, which was flowing, and the outer part of the lava froze. But on the moon, it is damn cold. There's no atmosphere to hold the heat in. But the lava continued flowing down through the middle of the tube. When the lava flowed all the way from here out onto the Mare floor, the tube was empty. And so there's nothing to hold it up, and the tube actually collapsed. We'll see in another picture the evidence for that. But the fact that the valley is discontinuous here tells you that the tube is still underground in the sections that haven't actually collapsed yet. Okay, that's called Plato Remi. The names probably aren't all that important. So, okay, the important thing here is what we've got is a sequence. We've got the anorthosite, the coffee mate material. That's the white stuff of the moon. That was formed at about 4.5 billion years ago. Major impacts forms the multi-ring basins, Mare Imbrium in this case, at about 3.8 billion years ago. Then more impacts occur, as we can see, even the Alpine mountains here are themselves impacted by craters, by meteorites making craters, some of which are large and complex, and whose margins then begin to collapse with landslides. And then, several hundred million years later, as the interior of the moon begins to heat up by radioactive breakdown of things like uranium, thorium, and potassium, heats the interior, forms the basalts which come up through the weakest part of the lunar crust because it's been impacted, here filling the Mare Imbrium itself and drowning out the ridges, and even starting to fill some of the late major craters. Well, we've got further story here. You see these little ridges here? Actually in the lavas that fill the Imbrium basin. Those are called wrinkle ridges. There's a bit of a discussion about what these wrinkle ridges are. Some people think that what they are is actually the fronts, the edges of different lava flows. And other people think that what these are actually is lava draped over faults which formed large cliffs or scarps, and so they stand out as drowned topography. The arguments continue. And then finally you get these small impact craters, nice simple impact craters, which obviously again are younger than these lavas. You can see most of this stuff with a relatively small scope. You won't see it with the same detail and resolution as Mike's image, but you can see this and tell yourself the same story. Next slide, please. Just very quickly, here is the Alpine Valley. Notice how it's got a straight side on one side, and it's got a rather complicated side on the other. It's not quite like the Ottawa Valley. It's got a major fault on one side, and then the other side dropped down, rather like a cantilever. And that's why the other side is rather irregular. But look what's coming up the middle of it. You can just see, you will need a very good scope for this, a large scope and excellent seeing conditions. But there's a squiggly valley going all the way down the middle, and this is an erosional lava river, hundreds of kilometers long. I've not put a scale bar on this one here, but that's easily 180 kilometers in length. And that was, I don't know which way that was flowing. But what you can see here again, you can see the rubble that was thrown out from the impact to form the Imbrium Basin. Next one, please. So here we are. We're at Plato here, and you can just see nicely the terraces, the collapsed terraces, and then this really large block that's collapsed down here on the side. So these are landslides within these craters. We'll go to the next one. Okay, we're moving over now down onto. That's right. That's right. We're now on the east side of Imbrium, and we're going to look at the Hadley Valley, or Rill as it's called. Before I forget, if we go to the next slide, that X there is the Apollo 15 landing site. And this is the feature, beautifully seen here in Mike's image. It's a meandering lava channel, it's an erosional channel, it's about 100 kilometers long and it's about 1 kilometer wide. Think about that, 1 kilometer wide river of lava coming at you and forming this. The speed it must have been traveling at as well to form 100 kilometers length of valley before it actually froze is also amazing. Now it's cutting into the lavas that actually fill the Imbrium Basin, so it must therefore be younger. But it may not be that much younger, because it may be a fact that it's an erupted lava which is related to the same event that actually flooded the Imbrium Basin itself. Note these rather straight, what they call rills. They're actually rift valleys. That's the nicest one you can see. There's another one there. These things form on the edges of these large impact basins once they've filled with lava. And you can see why. The impact basins are 12 kilometers deep. You've got 12 kilometers of basalt sitting where it was never before. So you've now got this huge weight sitting in the middle of this hull, which is the impact basin. So it pushes things down. And as you bend the edges of the impact basin, you stretch. And so you form what are actually rather narrow rifts, rather like, as I say, the Ottawa Valley. Finally, notice that there's an impact crater, a nice simple impact crater, which cuts right across the Hadley Rill, the Hadley Valley, so it must be younger still. And as I say, the X marks Apollo 15. Next one, please. Now we're moving over now towards the east. We're at the boundary here between Serenity and Tranquility, and we're in the area of Plinius. Next slide, please. Now this is interesting. You can see here the preserved segment, beautifully preserved curved segment of the outer ring of the multi-ring impact basin, which of course was Serenity. The other thing you can see very clearly marked here are these scars, which are, if you look down here, you can actually see the orientation. Mike's pictures aren't always north-south, by the way. So north is actually going over this way. You can see these scars, and those are the results of impact ejecta from an impact somewhere else, which has flown across the surface of the moon and literally ripped across it like a file, if you will. I don't know which impact this comes from. You might think it must come from Imbrium, but it's not quite the right orientation. And you can then see that this scarring is then drowned by the flooding as the Murray flood basalts come in. Notice this here. This change in color, even in black and white, the dark gray versus the light gray lavas. So there are two different kinds of lavas of different composition, and you can see this with a very small telescope. Notice something else here. You've got these long, narrow rills, as they're called. Here they are again. They're these long, narrow rift valleys, but they only occur in the dark lava. They don't occur in the light-colored lava. In the light-colored lava, you have these wrinkle ridges. What the hell's going on? Well, again, you're filling this hole with lava that was never there. So you're putting this weight on there. So again, you're bending the edges of the impact. The lava is filling the impact basin, and hence you're stretching them. And what's happening here is that as you bend something like this and stretch here, you're compressing the interior. And so what you're actually doing is you're actually shortening, you're compressing the lavas inside the basin, as opposed to the edge, and you're therefore forming these little ridges as the lavas are pushed up and overlap each other. It's what's called a thrust to geologists. So this is something which, again, you can see with a relatively small scope. And that means that if things are dipping inwards towards the interior of the basin, then these darker lavas are older and these lighter lavas are younger. So you can see we can actually pull together the geological history of the moon by simply looking through an amateur telescope. Now what comes out, if we look at the craters here, we've got older craters which are partially flooded. Those must have been there relatively early, certainly before the impact basins were flooded themselves. We got simple craters, we got complex craters, and in this particular case here, this complex crater is exactly as it should be. It's got a nice rim to it, it's got a nice central peak, and look at this, here's the ejecta blanket around the outside, perfectly preserved. And beautifully illustrated in this photograph, and it must of course be younger than the basalts. So again, you can tell the story of the geology of the moon in this particular area here. Next slide, please. So now we move up here towards Posidonius on the northeastern side of Serenity. And here we are. There's Posidonius, and this one down here is Le Monnier. And we're on the eastern rim of the Serenity impact basin. Now these two craters are both flooded with basalt. There's actually basalt in here and in here. You notice how the rim on this one here, Le Monnier, it's high away from the Mare Basin, and it's completely flooded. Whereas here, in the case of Posidonius, it's high here away from the impact basin, but it's low over here, and it actually has a gap. So what's happened is these lavas, when they came in and filled the impact basin, either came up through the floor, or they actually came in through or completely flooded the actual western edge of those two craters. Now, Posidonius is a large complex crater, and you can clearly see, beautifully illustrated here, slumping in its edges, as you'd expect. It forms these terraces and landslides, and those are pre-flooding. Now, you see these fractures in the floor here? These fractures are very interesting. Some of them are slightly curved, some of them are straight, but it's interesting that this one here seems to be cut right off by the basalts. It doesn't actually go any further than here. So it seems to, in fact, have been flooded. And what's happening is the basalt, as it came up through the floor, domed the floor up. And again, as you dome something up, you stretch it. And hence, you've actually formed little rifts in the floor of this complex crater. But here's an interesting one. There's what looks like a squiggly valley, and I'm not sure why. It seems too short to actually be an volcanic erosional channel. But it cuts right the way across the lavas, so it's even younger still. Finally, over here, you can see a rather long and complicated rift. It's got a complicated shape to it, but it clearly has two sides and a floor which is dropped down. That, again, is the result of stretching. But look what happens. As you come around, it actually turns into, I'm having trouble seeing it from here, I think it's right there. You can see it come around, and it turns into a ridge. So it goes from being a rift valley with a floor that's dropped to being a ridge with something that's been pushed up. And what this actually is, it's one movement, and I don't know which movement it is, but because the fracture itself changes direction, so depending on where you are on this fracture which is changing direction, you'll get stretching or you'll get shortening. And you again can see this kind of thing with an amateur telescope on the moon. So this is actually a very common feature. Next slide, please. In fact, I've got just two more to go. So here we are, we're over here on the north side of Serenitatis, and we're going to look at Lacus Mortis. Next one, please. Lacus Mortis is a really strange object. Not only has it got a strange name, I mean, it's the Lake of Death. I don't know who gave it this name, but the important thing is a lot of people treat this as a large flooded crater. There's a problem with that. Look at the shape. One dead straight side, another dead straight side, another absolutely straight side, ruler sharp, and then back again. It's a hexagon. Now you might say, well, okay, there's an easy way of explaining this. This must have been an impact into crust, the anorthosite, remember the coffee mate stuff, into the older crust, which already had fractures, which had a hexagonal pattern, so it just sort of pushed it down like a hexagonal piano key. That's a nice idea, but there's two problems with it. One, there are no hexagonal fractures. There are no fractures actually parallel to these walls in the rest of the rock anywhere. So that would be kind of weird. And the other thing is that geologically, tectonically, it's extremely difficult to make a hexagonal pattern of fractures. In fact, I know of no example on the Earth. You can make hexagonal fractures, but it's usually due to cooling, but not at this scale. If any of you have heard of the Giant's Causeway in Northern Ireland, which is actually a huge lava flow made of hexagonal blocks of lava, they're about, the biggest ones would be from myself to the camera, maybe from myself to Attila, but not this kind of size. I've got the scale bar up here. So I frankly don't understand this structure at all. But it's a fascinating feature for you to actually observe on the moon. It itself has then been impacted by the crater Berg, and you can see it's nicely symmetrical. It's a complex crater. It's got itself a nice central peak. Look at the huge landslide here on the, let's see now, north is that way, by the way. So on the west side, there's this huge landslide. And then here's the debris apron around it from the impact. So again, this obviously is younger than these basalts which have flooded, whatever this hexagonal feature is. Do have a look at it. I have no idea what it is. But the strangest thing here is this stuff down here. See these pimples? I don't know what they are. I've looked all over the place. I haven't done an extensive internet search, but I can't tell whether that's rubble that's been thrown out of an impact, or whether those things are small volcanic domes. I don't know, but the strange thing is nobody seems to be commenting on them. So let's go to the last slide. And we're going right over here now onto the east side of Tranquility, and we'll look at the area of Corci. Corci, Calci, pronounce it as you will. Here's the crater Calci. You're on the east side here of the Sea of Tranquility. And frankly, the most fascinating thing here, I don't know. There's a series of fascinating things here. Notice these craters here. They're flooded, and there's a fair number of them here. This is a fair ways out from the actual edge of the impact basin, and that's telling us, therefore, that these lavas are actually rather thin here, which is not surprising when you get towards the edge, since the floor of the crater, of the impact basin, is still poking through. So you form the impact basin then gets peppered by further cratering, and then you get the flooding by the basalt lavas. So you've got yourself a sequence then. But of course, the thing that was really fascinating from a geological perspective are these two lineaments here, one there and one there, which is a little more difficult to see, on either side of Corci crater. This one here is a relatively simple, this one here is a relatively simple rift, except that it's got a kink in it. I don't know if you can see, but it's just there. It bends around. Now, normally, I would say this is simply a segmented fault, which has formed two rifts, which are slightly offset from one another. But quite how they join there with that bend, I'm not sure. But it's telling us that the basalts were stretched. And the other lineament is this thing here, which actually goes from being a rift, which I believe is here, to being a ridge here. And again, what this is telling us is it illustrates the complexities of movement patterns when you get towards the end of a fault. You see this on Earth as well, but it's beautifully illustrated here on the Moon. But probably the most interesting thing, especially from the point of view of telescope observing, are these features here. And there are several of them up here. These are volcanic domes. These are the two largest ones and probably the easiest to see. They're volcanic domes, think Hawaii, but slightly smaller. And if you've got a really good telescope and really good resolution, and you can actually see summit craters on this one here. I believe there's a summit crater on that one there. And those are actually volcanic eruption craters. This is not recent volcanism. This is volcanism which is as old as the Murray lavas, which filled the impact basins, but they're the last gasp of that volcanism. So that's taken you through a tour of what I think are probably one of the most spectacular photographs taken by one of the best amateur lunar images in the world. But the real message here is this. You don't have to be Mike Wirtz to be able to see this kind of thing. You won't see the same resolution, but you can see similar kinds of aspects here, and you can tell yourselves the geological story of how various areas of the Moon actually formed through time and what the processes were. Thank you.
Was that great or what? We're going to have to get Simon back when he does figure out what those mystery bumps are so he can explain it to us. Mike Wirtz couldn't make it here because he couldn't tear himself away from that Baja paradise that he now lives in. But he asked for a copy of the DVD. So he's watching us right now through that camera, which means that he can hear your applause if you'd like to give Mike special applause for the pictures that he took. Mike is a good friend of mine, which means I like to nag him about whatever I can. And one of the things I like to nag him about is he should publish his pictures. And in honor of that, I would like to point out to Mike this atlas, which has these very nice large images of the moon. The information is in a plastic overlay, so it doesn't sully the beauty of the image. Sorry. Can you see that? The lunar images have the information on a plastic overlay. Whoops. So you can appreciate the image without having it sullied by the plastic.
The wave guide now. There we are.
Okay. And in the back are detailed photographs with some information about the geology. Mike, you missed the boat, especially because the pictures in this book are photographed by an amateur astronomer of the name of Thierry Legault, and I think Mike's pictures are better. But to instantiate my annoyance of Mike, I'm going to give this away as a door prize here tonight. So let's pick another ticket. I've got the box here. Pick a number. Oh, go ahead. Last three digits, 779. This, by the way, is a great atlas. Chapter still has a few of these left in Ottawa, but they're going to disappear soon. So after they're gone, we're going to have to bug Mike and Simon to write their own book about the moon. How many people here would like to see Mike and Simon write a book? Okay, so we've talked about what you can see, and Simon has educated us on the importance of the meaning of what we see. Now we're going to talk about how the machinery we used to see it, and specifically how we can get more of it, because we all love telescope stuff. Please welcome Richard Harding, who is an insider at Astromart, and Astromart is probably the most popular online place to buy and sell equipment.
Hi, Mike. Bastard.
The word bastard is actually an honorific. It's a prize awarded by the Ottawa Astronomy Friends for good achievement in astronomy luxury. Mike has won it 6 times.
Bastard.
Yes.
Anyway, this is titled The Rules of Acquisitions That Pertain to Astro Buying Online. Some of you probably have bought online, whether it's through Astromart or the Canada Buy Sell or the Cloudy Nights. Others may have thought about doing it, had some trepidation, what it entails, how do you send money to a stranger, what are the protections involved in doing that. I guess I'd say the other thing is why buy new? What are the advantages of buying used? Number one, depreciation. Let the other guy who bought it new suffer the depreciation. You get a lower price for it. In most cases, you won't pay taxes, and your shipping costs are probably going to be less. So here's our inspiration. People understood that money was everything in their mind. Rule of Acquisition 59, free advice is seldom cheap. You're going to get your money's worth tonight. When you sign up for Astromart, and we'll see that in a minute how you do that, take the time to read the terms and conditions of it. This is not a public service. This is run by a gentleman who is the owner of Anacortes Telescope and Wild Bird, and he makes the rules. You follow his rules, or he kicks you off. It's not a charity. So read the rules. They're not for all the 5 pages of rules. There's some very simple rules. You cannot advertise an item for sale on Astromart if you list it on eBay or another site, and you will get caught, because there's guys like me that are on a committee that check all of the ads. So just follow the rules, and it's a great place. The protections built into Astromart are second to none. When you sign up to Astromart, when you go online to astromart.com, this will be the screen that you're going to get. Down here is where you'll register. You'll log in if you're a member. If you're not, it will allow you to click on here and you'll be able to register. One bit of advice for it: when you put your email address that you're going to use, make sure it's an email address that you're going to be there for a while, because if you change email addresses, you're going to be charged for it. So if you have a choice between an office one, let's say that you know you're going to be there for quite a while, and a home one that might be transient, use the office one, because you will be charged if you change. So this is the screen you're going to get. There's news here. I never look at it. Classified, that's the buy-sell area where you're going to be able to purchase or sell your equipment. There's an auction area that's relatively new to Astromart, and it's kind compared to, let's say, eBay, it's a minor area. There's not that many, there may be 5 or 6 things at any given time. They do have a forum page, which you might be interested in. I do find the reviews to be very self-serving, so I don't take them as being all that serious. When you actually go to the classified, when you click on the tab for the classified, all the classifieds will be listed down here at the bottom. So you could go into eyepieces, click on that, and it'll give you all the eyepieces that are presently being offered over, and it's about a 30-day period. If you click on the bottom down here below the screen here, it'll give all of them to you, if you just want to scan and see what's going on with that. We don't have a lot of time, so what I've done is I've done 3 eyepieces, a low-end eyepiece, a medium-end eyepiece, and an expensive eyepiece, and see what can you expect to save or pay, and what's the advantage of buying it new. One of the things is that Astro people, unlike any other hobby, treat their stuff like it's gold or latinum. They treat it, they save the caps, they put the caps away and buy cheap caps to replace them so that the new caps don't get marked and that. So when you're buying from Astro people, in most cases, it's very well taken care of. This I've picked the Celestron XL Plosso, which is just a medium-range Plosso. There are better Plossos, but it's well made, it's well constructed, easy to pick up, it fit and finish is very good. So if we look at that, Canadian new price of $75, your tax of 13%, and shipping of $10. And if Kent's here, well, you buy it here, you'll save your shipping. But you're really looking here then at a total of $95. On Astromart, you'll pay $30 for that eyepiece. You'll pay nothing in taxes. The Canadian government does not tax anything under $150. It's not worth their time. So you're not going to pay any tax. Going to come through the border in a package with no tax, and you probably have shipping around $10 here. If you're looking at $40, you're going to save yourselves $55. You're going to pay less than half the price of buying it new. Better still, and this is one of the things about buying and selling used. When you're buying used, you're looking for an edge or an advantage. So when I look through this, and I find this one. So here's a gentleman selling an XL eyepiece with 3 clone eyepieces made in the same factory. They're just one of the ones branded slightly different. When you look at them, you see the fit and finish is about the same. He's selling 4 of them for $90, and it includes a aluminum case. I mean, you might end up saying, I want these 2, and resell those other 2, and end up, by the time you finish, each eyepiece cost you $5. But know what things are worth. It's important. This is an eyepiece that I happen to have. I think I have 4 or 5 of these I use for sidewalk astronomy. Find it very high quality. The Orion Stratus is basically the same eyepiece. There's some cosmetic differences, but they're made in the same factory. Really, Canadian new price $150, $20 of tax, shipping of $15. Again, I don't think you can buy that locally, so you're going to pay that amount there for a total of $185 for that eyepiece. Go on Astromart, 6mm eyepiece, $75 firm price. No bargaining going on. He says it's firm. Anyway, and it's a Canadian purchase, which means that's great too. You'll pay less for shipping. But he says he'll pay the shipping. Better still. He'll probably pay the shipping and take $70. I like these rules, Vac. Opportunity plus instinct equals profit. Works for me. So here's your Astromart price for the Hyperion, $75. There will be no tax on it, and $15 for shipping. And in this case here, you'd have gotten rid of that. Savings of $95 on the eyepiece. Hard to go in and plonk down $185 when you can get it for $95. The mother of all wide eyepieces, for most of us, would be the 31 Nagler. Walk into the store, it'll be $7.99, tax $104, shipping $15, total of $918. There's a lot of people here, scopes don't cost $918. Oh, I like this, eh? Hear the profit in the wind, eh? Keep your ears open. Okay, I went through there, I picked a few of them, here's one of them. And when he says it's in excellent condition, if there was so much as a hair or a scratch on anything, he would spend about a paragraph explaining it, because people are deathly afraid in Astromart of getting a bad rating. If you get a bad rating, you'll have a hard time selling on Astromart. People will avoid you like crazy. And the 5-star system, now you'd look at this guy here and say, well, William's got 1 rating. It's more risky than someone's got 150. But chances are he's starting out, he's trying to build his rating system. There's a bit more risk there. But in 140 transactions that I have, I've only had 1 bad transaction, and that got fixed. So relatively safe. What else do we see here? Well, one thing you might have, and it's not shown here, but it might say CONUS only, which is continental United States, which means no Alaska, no Puerto Rico, no Canada. I have not hit 2 out of 100 that have said they wouldn't ship to Canada. They say CONUS, but if you say, would you ship to Canada? They say, yeah. So keep that in mind. Don't shy away from that great ad you see because it says CONUS or US only. So there we go. Astromart price of $490 US, tax of, you're going to pay tax on that. When that one comes across the border and he's got the value as $490, they will tax you. You'll be hit with 13% tax, so that's $80 US, and $22 US for shipping, $592 total. Taking that at an 80-cent dollar, which we're better than that now, $740. You'll save at least $178. Proving your lobes. Anybody who knows about the Ferengi and knows about Star Trek, proving your lobes is to show your manhood through purchasing and wise buying.
Enough Umax.
I'm Quark. Okay, so do your homework. This is like anything else. If you go in unprepared or in blind, you'll get skinned. So make sure that you do it. Know the real price. Before you go out to buy that eyepiece or telescope, find out what the new price is. Find out what it is in the States and what it is in Canada. Know what you're dealing with, what is a true value of it. Research the best prices on Astromart. Even though Astromart only show you the last 30 days, if you go and do an advanced study, it will give you back 2 years. So take it back 2 years, look at every one of that eyepiece or telescope that's been sold, and see what the prices were. Average them out. Know what's a good deal and what isn't. And one other thing too, boxes and caps and things like that matter a lot when you're selling. So when you're buying, make sure they're there. If somebody sells you a Nagler and it doesn't have the box, that's a discount of $20, $25. So it matters that the paperwork and that the box and the caps are there. Because one day you may want to resell that and you're going to be paying that guy's $25. Buy Canadian on high-end purchases. Because if you want to avoid that tax, if it's shipped from within Canada, of course, there'll be no tax on it if it's a used article. Be friendly. If you treat it like a business and you're too harsh, people will not sell to you. They'll pick up your tone in your email. Next thing you know, I already have 2 other offers or something. I'll let you know. You'll never hear from them again. Because after all, this is a hobby. Be friendly like you want to be treated, and it'll go a long ways towards making a deal and building the trust. And don't be afraid to offer below the price. You can only go up. So make sure that you make not an offensive offer, but make an offer you think is fair, and go from there. And try to limit shipping costs. It kind of defeats the purpose of buying used if you pay 2 or 3 times what it really costs to ship. That's why I don't buy on eBay. $14, $900 in shipping by the time it gets to your door, so be very careful with that. And as I said before, CONUS, in most cases, sellers will send to Canada. Dues. Be patient. Don't buy that, there's going to be there's another bus coming around, and well, not here. There used to be buses. What a bad analogy, eh? Buses, eh? There'll be another one coming around, so don't jump on something and think that's the last you'll see and pay too much. If you're trying to If you're really trying to save what you pay to have more money to buy more things, be patient. Be honest. If you're selling, don't over-represent your product. If you tell somebody it's brand new in the box, but there are some scrapes or brushes or rubs or things, tell them. Because it'll only hurt you if you misrepresent your product. If it's too good to be true, it probably isn't true. This works everywhere, and it certainly works in buying. If he's talking about like it's the best thing you've ever seen, this scope was hand-picked from 560 scopes, the best one they ever made. Yeah, okay. Avoid sellers and buyers with bad ratings. If a rating system is going to work, then you have to avoid people that have bad ratings. If they treated somebody else badly or didn't deliver in what they said, they're probably going to screw you as well, so avoid them. Follow the terms of use. Talked that before. Oh yeah, I like this. Nothing is more important than your health except for your money. How can you appreciate your health if you don't have any money? This is very important. Make sure when you're negotiating with somebody online that you both understand the terms and conditions. What are you selling? What are you buying? What is his opinion of excellent condition? What is your opinion of excellent condition? How is he going to ship it? These are important. Make sure that, to the point of maybe annoying him with extra emails, make sure that you're on the same page. Ignore negative feedback. In other words, I'm just saying, ignore people with negative feedback. Don't buy, don't sell. But don't be flippant about leaving negative feedback. Just because you didn't quite like the way he acted, or maybe you don't think it's 100% what you expected, don't leave negative feedback lightly, because it hurts those people on the other end. And it's hard to get that back. And if you just flippantly put in there that, well, I didn't really like dealing with him, don't hurt him, because he'll turn around and he'll track you down, and he will leave you negative feedback somehow, some way. This one's in red for a reason. Never, ever, ever accept any shipping other than United States Postal Service.
A lot of people learn why.
Oh yeah, here's the why if you don't know. UPS, FedEx, even our friends at Purolator, our Canadian friends at Purolator, will charge you a so-called, what do they call it? Brokerage. They can't, because it's not really a brokerage fee. They're not paying the government anything for it, which is what a real brokerage fee is. It's just a sting. They're taking money away from you. They hold the object in hostage till you pay that money. Why does it happen? Is because UPS will sell that service to the person sending it for less than they can send it by post, because they know they're going to get you in the other end. So never, ever, ever accept that. Unless if you're willing to pay that, that's fine. But then what's the point of buying used? Don't forget that this service is not a business, and thus the site owner, who is Herb York, has no obligations to you. So don't act like you're buying something and he should and the site should, because he'll just cut you off, say goodbye. Do not fail to read the terms of use. Home is where the heart is, but the stars are made of latinum.
While I'm not observing, I spend an inordinate amount of my time lusting after things on Astromart. So this is a great talk for me. Did you guys enjoy it too? One should realize, though, that the most important astronomical accessory is not the wonderful equipment that we spend so much time lusting after. It's actually observing buddies. And I proved this to my surprise a couple of years ago at Starfest, when I had an absolutely wonderful time in a 95% covered sky. Because I had fun observing buddies, we used deep sky averted vision techniques to observe Vega. So, observing with people makes observing much more fun. That's why clubs are important. That's why we're going to talk about our club. And to do that, please welcome our new president, Paul Harrison. And after Paul, we're going to talk. So Paul's going to talk about what the club is. And
We don't have any video here, so give me a second.
okay,
Just switch over to the other sheet.
Okay, let me tell you about my summer vacation. Oh, no, after Paul, we're going to, Mike Mogdenham is going to talk about what this club and other people could be doing in the future. So now we're going to talk about club and activities. And just to make up for this lack of section where you can see pretty pictures, we'll have some pretty pictures afterwards, sort of like dessert. Do we have video?
Start now.
Do you want to talk about that video?
I can talk, just the power fell out of the machine here and it went to sleep, so I'll just bring it up here.
Okay.
Maybe I won't.
All right. Well, I know the evening's winding down, so I'm not going to keep you too long here. But,
There he is.
okay.
You're on.
All right. All right. Well, good evening, everyone. First of all, I'd just like to say I was very honored to be nominated as president for the Ottawa Centre for this year, which promises to be a very exciting year, not just for our centre, but for the RASC and for amateur astronomy in general. Just a quick background, just so you know who you're going to be stuck with for the next year at least. I just worked it out the other day. I've been involved in amateur astronomy organizations almost 15 years now. The RASC itself I joined when I lived in Toronto a few years back. Then I joined here in Ottawa when I moved here about just almost 5 years ago. And I've actually been on council for the last 4 years. The last two I've served as vice president under Chuck O'Dale. I can try to see if I can see. There's Chuck right in the corner there. So Chuck, who I guess we all owe a great deal of gratitude for 2 years of solid service as president of our organization and steering council and representing our center to the outer world. So thank you again, Chuck. So, oh, perfect. Yeah, that'd be great. Okay, so I guess the first thing I wanted to go quickly over is just briefly what is council, and I sort of see council as having three main roles, and I did my best to make sure they all start with the same letter so that we'll remember them easily. So we'll go to the first one. So this is going to be 3 O's. So we'll start off with operations. So council is responsible for the daily, weekly, monthly, yearly operation of the organization. That includes memberships, that includes the annual dinner, that includes many things. A very important thing it includes is the budget and finances. And under Hans Brouwer, our treasurer, we completed a very intensive audit this past year. And as we saw in the budget that was presented, the finances were presented back in December. Our finances are still overall in very good shape. We did post a slight deficit last year, which one of the things we're going to be focusing on this year are ways of trying to reduce costs somewhat while still providing the same quality of service to the membership. Number 2 is outreach, and of course, in any year this is an important thing, but particularly this year being the International Year of Astronomy. And you're going to be hearing a little bit more about that from Mike in a couple of minutes. We participate very closely with our meeting hosts, the Canada Museum of Science and Technology, and organize star parties and various outreach events for the general public. Okay. And our third O is organization. By organization, I mean our parent organization, the Royal Astronomical Society of Canada. And we have 3 members on the National Council for our centre, which gives us a fairly strong voice on issues that matter to membership. And so there's many probably aware there's a lot of discussion recently about the changes to the way charitable status is considered by the government, and of course that's going to be an issue that's going to be looked at quite intensely this year as well. And so we're going to be, as council, involved in that discussion also. So that's in a nutshell what council does. So next, who are we? So we go to the next slide. So you've already met me, Al Scott. I don't know if Al's here. Oh, hi Al. Al's our vice president. Is also runs the library, the telescope library, and his day job he builds a really big telescope that's going to go out to the Lagrange point. So telescopes of all sizes. Chris Turon is not here. Chris is our secretary. And he's also often the guy behind the console, or industrial light and magic representative. Hans Burr, I've already mentioned, is our treasurer. He's been doing a fantastic job in again, with the audit last year, and he works for the Canada Customs and Revenue Agency, so he knows taxes, he knows money, so he's been a very good asset to our council. Councillors, large, Yves Demare, sitting there. Carmen, I believe over on the my left, your right, and Stephen Norse, sort of back center. Center meeting chair you've met is Attila Danko. So, thanks Attila for tonight's show. National Council reps, I mentioned we had 3. Deborah, I don't know if Deborah's here. Don't think so, no. Barry Matthews, Barry is there. And Chuck, you way back in the corner again, who's also our past president. And very quickly, these are positions that are appointed by council. Stanmont Library, Estelle Rother, is Estelle here? Estelle is there. Webmaster is Richard McDonald, the guy who's behind the controls for this evening. Astronauts editor is another Paul Weffers Betink. Al Seaman is the director of the Fred Lossing Observatory, which is a members observatory just outside of Almont. Al, are you here this evening? No? Okay. He's in Florida. Another guy somewhere warm. Okay. Our SmartScope director, Doug George, is over there. SmartScope is our sort of telescope on the internet. It's located out at the Shirley's Bay campus near where I work. Light pollution coordinator this year is Gary Boyle. Gary's over in the far edge there. Sorry, I almost skipped one there. Public outreach, you'll hear from Mike afterwards. Mike is sitting there, but you'll hear him talk about outreach in a second. Hospitality, Art and Ann Fraser. Basically, the goodies you see in the hallway after the meeting, those are all courtesy of them. So, Art also moonlights as our membership representative. So, if you want to renew your membership or get a new membership, if you're a first-time visitor here, then he's the guy to talk to. And I've already mentioned Al as being the Telescope Loan Library. So, without further ado, I guess I'll hand the podium over to Mike. Hand the mic over to Mike.
Oh, that's fine. That's great. Thanks. Terrific. I will. Okay. Hi, everyone. I know we're over time here, so I'm going to go very quick. So fasten your seatbelts, and we'll go through this fast. I'd like to give you a quick overview of some of the public outreach events that we have planned for 2009. It's obviously a very exciting year with International Year of Astronomy. So I'll just lay it out here. Next slide, please. So you may remember from an earlier email I sent out a couple of days ago that I sent out an appeal for volunteers because the museum was hosting the launch of the IYA Canada launch, which happened yesterday. So I wasn't entirely sure that the launch was going to proceed until a couple of days ago, and then I heard indeed it was. So we were very excited about that. We asked if the Ottawa Centre could be involved, and yes, indeed, the museum said yes. And I got a couple of photos from the event. The media was invited, and there were several prominent speakers. I'll point out a few of them to you. In the top left corner there is a fellow named Jim Hesser, and he is the IYA Canada single point of contact. He's the one fellow that's sort of both the strategic lead and so forth. Very, very pleasant man to deal with, and just full of enthusiasm. I think he's is it the Hertzberg director as well? I think out in Victoria. There was various people who showed up in the bottom right corner. They had invited 2 Mi'kmaq natives who shared their story of the night sky, and maybe go to the next slide. We had an awesome telescope display, so I think we added a tremendous amount of depth to the event. Right after the speakers had finished, declaring the start of the IYA, the media came around and filmed and did a lot of filming of our telescope setup. We had a big display. We had tables set up with the IYA Canada literature that I brought in to share with you tonight. Brian McCullough was brought on some meteorites. Rob Dick had his light pollution display, and Kim and Joe Silverman and Michael Alon were there as well, as was Deborah. So next slide, please. So that's Jim Hesser in the top left, in the middle there, and posing with us. Next slide. I got to say that, I mean, you probably remember it was yesterday it wasn't the nicest drive, so it was a very sort of stressful event here, and as you can see, that was very taxing on some of us here. Joe Silverman was was giving his best. Joe had a very special thing happen to him yesterday. He became a vegetarian. Now, Joe will have to tell you the story. But joke aside, I can't thank enough the people who showed up. As you know, it was a bit of a last minute appeal, and it was just a terrific showing. We got tons of accolades. I think we really, I don't know, how many people saw this event on the news? Did anybody see it on the CBC or maybe later on? A couple of you. So I was quite pleased, and I think there was a CBC camera, and we think there was another one, a native film crew there. There was an author that was there as well, who was assembling a book with the event like this. And I think there was Discovery Channel what we were thinking was there as well. Okay, so all in all, went very, very well. So you may remember in November I talked about the Galileo lecture. This is one of the flagship programs of IYA Canada, and what this was all about was that a series of, I think it's 10 prominent astrophysicists are in this program. They are paid to go across Canada to deliver presentations to the community. And these people are not just prominent in their field, but they're also they were picked to be as speakers because they're engaging. They're very they're fascinating to listen to. I feel quite fortunate. Our application was accepted. You may remember in November I talked at length about how this very elaborate application process. So we put an application in, and we're really happy that it came through. The fellow that we have is Roberta Abraham, and I went and I did a bit of research about him, and he's a professor of astronomy and astrophysics at the University of Toronto. He's the principal investigator of the Gemini Deep Survey, and I kind of stumbled onto one of these websites, the Rate Your Professor website. And there was nothing but compliments from his students describing him, filled with passion. And I guess, Al, you know him, I guess, from your work. You sort of share the same view. That's terrific. Yeah, so this is going to be a big event for us. Next slide, please. Okay, so I wrapped a lot around this. Okay, this speaker. I mean, that's really what what they wanted us to do. And when you're applying to get a speaker like this fellow, so we're leading up to the event. We're going to involve high school students in creating an IYA poster contest. I am going to apply to see if I can get someone from someone from the Canadian Space Agency, either a former or a current astronaut. So that's a process I'm going to be starting right now. I feel I will be able to get a former one because I've actually, I know a former astronaut who I invited to for a previous event. The day of the event, there's going to be lots of other things. I won't go through the list here. We're thinking it's probably going to be held at either Carleton or University of Ottawa. We're going to need a big forum of about between 4 and 5, a big theater to house for about 400 to 500 people. Okay. Next slide. So what's next? It's what I describe here. We got to get going. There is a development committee. I list the names of the people who were involved in the preparation of the application and who also have come forward and said they'd like to be involved. I welcome anyone who would like to be involved in this event. I'm going to be talking about this every single month. Okay, as we progress and have the event. I'm thinking it'll probably be in our application. I said it would be either in April or May. If you have some time, little time or a lot of time, let me know because this is going to take a lot of planning, but at the same time, it's going to be a lot of fun. Okay. Okay, so a view ahead of some of the outreach events that I am planning, and at the same time, some noteworthy dates as well. So I talked a little bit about the Galileo lecture, and again, how that'll happen in April or May. Some of the other things I'm looking at, and just the planning is underway, is that there's a global IYA event, 100 Hours of Astronomy, and this event is scheduled for, it's like the Galileo moment that Deborah Sarvella talked about in December, where you're looking to get as many people as possible to look through a telescope, just as Galileo did 400 years ago. I'm planning on connecting into a 24-hour global webcast from many observatories. So this is something on the that we're going to wrap an event around and publicize it and promote it. Celebration of the 40th anniversary of the Neil Armstrong's Apollo 11 steps on the moon. It's one thing that it's funny. I haven't seen that promoted all that much, but it's this year.
Right? Don't forget Buzz.
Buzz Aldrin too. That's right. That's right. And the rest of them. Okay, something else that hasn't gotten much attention. I think some of you know about it, but I wanted to sort of make everyone in the group aware of it. It's something called Cafe Scientific, which is actually, when you research about this on the web, it's actually a global program. But the museum here is hosting it locally and is involved with it certainly in Ottawa, and I'm not sure, they might be involved with organizing this across Canada, but certainly in Ottawa. And what it is it's a forum they organize a forum to discuss what they call controversial issues in science, and one aspect of the program is that it's intended to be informal and particularly accessible. So these events are held, in fact, and this one here is held at the Fox and Feather Pub, okay? And the idea here is that it gives, as I said, people who aren't normally engaged in these kinds of discussions or dialogue an opportunity to ask questions, to share their views, and so forth. And so the museum approached us and asked us, do we have someone that could participate? And we offered a couple of names, and Brian will be there at the Fox and Feather on January the 27th. So if you have some time, I'm sure Brian would appreciate your support. Okay, next slide. All right, so one of the things I wanted to do is I wanted to share with you really quickly here a series of, I see a lot of creative National Year of Astronomy advertisements that and promotions from various groups. And one of them came up from a fellow with the fellow's name is Ray Jawahardana, and he's with I guess he's a professor of at the University of Toronto and involved with the Dunlop Institute for Astronomy and Astrophysics. And he came up with these ads there are actually 3,000 of these colorful ads, colorful, thought-provoking ads that are now appearing as of a couple of days ago on TTC buses and subways and so forth. So if you're in Toronto, you can look for these. I was really taken by these. I thought this is tremendously creative, and I wanted to share with you 4 of them before I close. So I'll give you a second to read it. So just imagine yourself sitting on a subway or on a bus, and you're looking up and see something like this. Next slide, please. Another one. I'll let you read it. I think it's really well done. It's quite taken by that. Next slide. And the next one, Richard. Don't you think it's they're short? They're very very. It catches your eye. And I have to tell you, when Chuck brought this to my attention, and somebody else brought it to my attention, and I thought, oh, I'd love to bring this to Ottawa. So part of me is thinking, well, what if there's something I can do to bring this to Ottawa? Who knows? I think last slide. Oh, there was another one. Okay, and very last slide. Okay, so last thing I want to leave you with is that the official Canada IYA site is there in English and French. There's so many things that are happening. If it's a cloudy night or anyone, or you just want to explore the web, I encourage you to go to the site because there's just so much on here. And there's lots of groups that are sharing ideas on what they're doing for outreach on this site. If you see something that you think is interesting, I'd really appreciate it, sort of bring it to my attention, because this is what it's all about. It's our year to shine. So thanks very much, Earl.
Yeah, it's okay. Thank you. That's the end of the formal talks for this evening. I just thought we'd give some thanks for who made this meeting possible. On top of the list are you, the audience. 159 of you showed up tonight, because we wouldn't be here giving this presentation if there was an audience. So this gives me to the key question, the most important question tonight. Did you guys have a good time? I'd also like to thank the huge crew of people who helped put on these meetings. It's not just all my fault. I'd like to say thanks to Chris Terr and Richard McDonald and Brian McCulloch, who without their help, I'd still be here trying to figure out how to connect the audio up this morning, today. Next, please. We've arranged some post-meeting entertainment for you. In addition to the book and equipment library, outside we'll have conversation and coffee and little carbohydrates. This is your opportunity to go up to our speakers and tell them what you liked. Please note that the people who come here and talk to you are not compensated in any way. They don't get any health benefits. They run entirely on thanks and enthusiasm. If you saw something or heard something you didn't like today, please tell me and I'll administer the beatings in private. Your hosts, Ann Fraser and Ann and Art Fraser, will be handing out the goodies. And the rest of the museum is closed. Next, please. Later tonight, some of us will be going to Kelsey's, just up the street, for those people who need alcohol in order to have a relaxing conversation. Next. We don't have a regularly scheduled observing session at our club's observatory near Almont, the Fred Losky Observatory, but I suggest if any of the members are going out there in the next month, please post to our mailing list so that we all know, because it's much more fun if you have an observing buddy. Next. I will be trying to have an observing session at my observatory with my telescope there, and on January the 24th, assuming it's clear. So look for a posting on the Rasc mem list. Next, please. The next meeting will be Friday, February the 6th here. And one thing I'd like to suggest is that if you have any old astronomy magazines that you want to give away, bring them in. We can have a magazine swap. But more importantly, and this is of course the hard part when I have magazine swaps, I volunteer to take the leftovers home, because what I do is I hand them out at public outreach events. I find that the public is very interested in getting free stuff, and magazines are a really nice way to get into the hobby. Now, as I mentioned, we're going to have a little pictures to look at. Think of this as eye candy or dessert. I'm going to show a video that I swiped off of YouTube just to get people excited about solar observing, assuming we can get the computers to work.
Not until it will dance. No, I don't think there's a player on this machine. So
okay.
the answer would be no.
Okay. It'll be breakfast next time. Sorry. That's the meeting for tonight. Please have a good time and a safe drive home.